Hello students, in this video we are going to solve objectives from practical number 1. First objective is a graph that has vertex chromatic number 1 is kn n greater than or equal to 2 cn kn bar. Kn bar means kn complement, that is null graph on n vertices. Null graph on n vertices, and last is km comma n, that is complete bipartite graph on m plus n vertices, where one vertex set contains m vertices and another vertex set contains n vertices. So I am drawing k2 here, kn, and for n greater than or equal to 2. So I have drawn k2 here. We can color this vertex by using color 1, and to this we have used color 2. So vertex chromatic number of k2 is 2. So option kn for n greater than or equal to 2 is incorrect, because we want to find a graph with vertex chromatic number 1. Cn. We know that chromatic number of Cn is equal to 2 if n is even and 3 if n is odd. So this option is also incorrect. Kmn. Vertex chromatic number of bipartite graph is always 2. So this bipartite graph, and it has vertex chromatic number 2. So this option is also incorrect. So Kn complement is a correct option. Null graph has vertex chromatic number 1. Let us draw here null graph on n vertices. Suppose this vertex is v1, v2, v3 and so on, vn minus 1, vn. Since there is no edge between any two vertices in this graph kn bar, we can color all these vertices using single color. So chromatic number of kn bar is 1. Option C is correct option. Next objective is vertex chromatic number of a tree on n greater than 1 vertices E. So let us draw a tree where number of vertices greater than 1. So I have drawn here a tree T, V1, V2, V3, V4, V5. So here n is equal to 5. Now I am coloring the vertices of T. So I have colored vertex V1 with color 1, 2, V2 with color 2. Again I can use color 1 to V3, color 2 to V4 and color 1 to V5. So chromatic number of tree is equal to 2. N is equal to 5, but chromatic number is not equal to 5. So this option is incorrect. Chromatic number is not 1. So 1 is also incorrect. 3 is also incorrect. Option A is correct option. Now third MCQ is vertex chromatic number of a cycle. C is 3 if length of cycle is. In first MCQ, we just discussed that chromatic number of a cycle is 2 if it is a cycle on even number of vertices, and chromatic number is 3 if cycle has odd number of vertices. So here they have given chromatic number of cycle is 3. So that means cycle should have odd number of vertices. So option A is correct option. Fourth option is, let C be a proper coloring of G, vertex graph G with vertex set V and edge set E using T colors, then the coloring partitions V into. Okay, so I am drawing here a graph. V1, V2, V3, V4. Okay, so let us color vertices of this graph G. So 1, I cannot use color 1 to V2 as V1 is adjacent to V2. I cannot use color 1 to V3 also. So I am coloring V2 by color 2, V4 by color 2, V3 by color 3. So chi of G is equal to 3. 1, 2, 2, 3. Okay, chi of G is equal to 3. Now I am considering sets. Suppose set S1 is equal to all. I am collecting all the vertices with color 1 in S1. So color 1, the vertices with color 1, there is only one vertex V1. I am considering all the vertices with color 2 in S2, that those are V2 and V4 and vertices with color 3 in S3. There is a single vertex with color 3. So this vertex set of graph G is nothing but V1, V2, V3 and V4, and it's partitioned into 3 parts, and it has chromatic number also 3. So if chromatic number of graph is 3, then we have partitioned the vertex set into 3 parts. Similarly, if chromatic number of graph is T, then we can partition the vertex set into T parts. Option T minus 1 would be a correct option if we get 2, but here chromatic number is equal to 3 and we cannot partition the vertex set into 3 minus 1, that is 2 parts. We cannot partition this set into 2 parts and 1 part also. So option C, D and A are incorrect option. Fifth MCQ is the minimum number of colors required for proper vertex coloring of a null graph on P vertices E is. Actually we have discussed this in our first example, but again I am explaining. Suppose this is a null graph on P vertices V3 and so on, VP minus 1, VP. This is a null graph on P vertices. So we can assign same color to all these vertices as there is no edge between any two vertices in this graph. So chromatic number of null graph is 1. Now next MCQ is the vertex chromatic number of complete graph Kn is. So let us draw K3. This is K3 and chromatic number of K3. We are going to find chromatic number of K3. I can assign color 1 to this vertex, color 2 to this vertex and color 3 to this vertex. So chromatic number is 3. Now K4. I have assigned color 1 to this vertex, say A, B, C and D. Now A and B are adjacent. I cannot assign color 1 to B. So I have to assign color 2 to vertex B. If you go to vertex C, we cannot use color 1 and 2 to C because B is adjacent to C and A is also adjacent to C. So we must use color 3 to color vertex C, and similarly we cannot use colors 1, 2 and 3 to color vertex D as D is adjacent to A, B and C. So we must use color D, color 4 to vertex D. So chi of K4 is equal to 4. Similarly, you can see chi of K5 is equal to 5. So if you observe option B, n minus 1. So chi of K3, 3 minus 1 should be 2, but chi of K3 is not 2. Chi of K4 is also 4 minus 1 is not equal to 3. So option B is incorrect. Option C is also incorrect. N by 2 is also incorrect. So option A is correct option. Now 7th MCQ is the vertex chromatic number of a bipartite graph XYE is. The vertex chromatic number of bipartite graph is always 2. This is a standard theorem. Vertex chromatic number of bipartite graph is always 2. Bipartite graph is 2. So we can see example. Suppose this is K3, 2. So we can assign same color to vertices in set X. Suppose A, B, C are the vertices in set X and D and E are vertices in set Y. So we can assign same color to A, B, C and another color, same color to D and E. So you can easily color bipartite graph using only 2 colors. So vertex chromatic number of bipartite graph is 2. So option A is correct option. Now last MCQ in this video. Let G be a connected graph. If G is neither complete nor an odd cycle, then vertex chromatic number of G is. So let us consider an example of a graph which is neither complete nor an odd cycle. So this is a graph and G is neither complete graph nor an odd cycle. Okay, so let us find chromatic number of this 1, 1, 2, 2. So chromatic number of graph G is equal to 2 and maximum degree of graph G is equal to 2. So if you find option C or if you observe option C, this is maximum degree plus 1. So what is maximum degree plus 1 in this graph? 2 plus 1 is equal to 3. So vertex chromatic number of G is not equal to 3. So option C is incorrect option. Less than maximum degree of G. Maximum degree is equal to 2 and less than 2 means it should be 1. But chromatic number is not less than 2. So option A is also incorrect. Option B is correct option. It is equal to maximum degree of graph G. So in this video we have discussed first 8 objectives. In our next video we are going to discuss another remaining objectives from practical number 1. Thank you.